Hey guys, welcome. We're just going to walk you through the lesson that you guys hopefully did in class yesterday without me. Um, and so this is kind of just to help you with what we should have learned through that if you didn't. So here we go. We're entering a unit called algorithms. So we're looking at how can we write a program, how can we write code that will generate something for us to solve a problem. So our first thing is I told you to take out a paper and write this down. This is what you're going to be doing while I'm out uh, for the next most likely week because of COVID. I'm doing fine and healthy, but yeah, probably won't be able to come back until next Monday. All right, so first thing I'd ask you to take is what makes two pieces of code the same? Could there be two pieces of code that you consider to be the same even if they aren't identical? So when we say two pieces of code are the same, a lot of us would think that means every line of code, if I said, hey, is this code the same? You'd say it's 10 lines. Every 10 line has the exact same thing that's the same. Or it could be, and we'll use this a lot, a square. This code makes a square and this code makes a square, but they do it in two different ways. So we could have a code that does the same thing, but does it in a different way. And that's kind of the thought process we want to get to, is that I could tell a whole class to create a code that will play a song, after, someone clicks a button and something like that, and everyone's could look different. Yet they do the same thing. So we want to look at how can we best utilize those different methods. So I asked you to go through and talk to people to find a person who has a birthday before yours, after yours, closest to you before, closest to you after. Find a person whose birthday is closest to yours. Hopefully, usually we get some people with birthdays on the same day, which is kind of fun. So I'm bummed I wasn't there for that. Mine's June 28th, by the way, so if that helps anyone. Find the person with an equal number of birthdays before and after theirs. Okay. Find two people with the closest birthdays in the room, so if they have the same birthday, that'll work. Find the shortest period of time which 3 people have birthdays. Find the shortest period of time which 4 people have birthdays, and find the longest period of time in which no one has a birthday. And that would probably include years you could do if you want. So if you have like someone really young and someone old or something like that. And so this could take a while to answer these questions. You might want to think, how am I going to figure this out? There's some strategies that you could do for this. Obviously, I wasn't there. I don't know how willing the sub was to work with you on this. But I think doing a Google Doc and sharing everyone's birthdays and organizing them would probably be a really fast way of doing this, and then being able to figure this out. But the next question came with, how did you go about solving? So if we did get like a group class together to think about this, maybe you came up with, yeah, let's share all of our information in Google Doc, or maybe someone just started, hey, June's over here, July's over here, September's over here, so it depends what you guys did. And then which problems did you need to do something similar in order to solve them? So if you go back, a lot of these, you could easily find someone whose birthday is before yours, by just saying, hey, when were you born? Or if you're a senior, you can really find someone fast. And find a person who's after yours. If you're not a senior, you can find a senior. That would be really fast. But these other ones, you might take different strategies to find. But most of them are, in the order of which these are. And so you could use very similar tactics for those. So after that, we looked at 6 different algorithms here and decided which of these are the same as one another. If you look at them, none of them are truly the same, as far as none of them look the same. But we have algorithm 4 and 6 are both written using a flowchart method. Algorithms 1, 2, 3, and 5 are written using a pseudocode type method. But we find here that some of these are going to make a square, and some of these are going to make a rectangle. And so if you're able to figure that out, what'd you get? and you should come up with 1, 3, and 4 turn out to be a square versus 2, 5, and 6 are a rectangle. So if you're able to figure that out in those ways, those are the same because they end up with the same shape. But even so, we have ones that move right 3 times in order to make, or sorry, move left 3 times in order to make a right, versus just turning right. So there's a lot of different ways and approaches that we can come up to how we're going to do something. And some are better than others. And again, we're going to get into this idea of algorithm efficiency. So when we make code, we can do it in the fastest way possible. And we're going to get into the concept of when can we not do something or create an algorithm that is efficient at all. And so if we look at these, I would say most likely algorithm 2 looks very efficient for generating this shape, but that would be a rectangle. But for a square, maybe it's, say, algorithm 1 or 3. And so you could kind of debate between those, which would be more efficient. 4 and 6, no matter what, I always think flowcharts don't look efficient to me, but that's just me. So anyways, moving on. So you're supposed to discuss and how you decided it. We just talked about it. And then wrap up overall, we're looking at a problem, which is a general description of a task that can or cannot be solved with an algorithm. So not everything can be solved with an algorithm. Again, an algorithm is just a finite set of instructions that accomplishes the task. So every time we write code, we're technically writing an algorithm because it's a finite set of instructions. There are usually many algorithms to solve the same problem. So lots of different ways to do it, and many ways to write or express one algorithm, including natural language, which we talk about all the time, pseudocode, diagrams, or implementing using program code. For example, we use JavaScript. All algorithms can be created by combining steps in 3 different ways. So sequencing, we put them in order. Selection, which is we decide which step to do next based upon a Boolean event. And then iteration would be doing a step repeated over and over again. And you could also include a selection is usually within there because at some point it needs to stop. So it has to check some sort of condition to say, hey, should this stop or not? And so those are the 3 different ways that we will think about how are we going to create an algorithm. So how did today's activity change the way you think about algorithms and problems? Maybe it didn't. Hopefully you're thinking about there are lots of ways to do the same, answer the same problem, but there might be better ways, and that's what we're going to dive into next time. So yeah, I hope the lesson went good, and I will make another follow-up video for the lesson that you guys do in class. So you'll want to watch that before the next one.